I hope you guys watched our video from last week on the main T-Rex Arms channel about civilian legal explosives. Not only was it fun, but it was educational, but kind of in a starting the conversation way, because a lot of the civilian legal explosives that you can own, possibly more than you thought, but also in some ways a little bit of a letdown. Most of those things are basic black powder. Useful, but this is not exactly new technology. So in this video, I want to talk about the future of civilian legal explosives, or at least civilian usable, sort of general use explosives, because I believe that it will not be black powder. Obviously, black powder has many fine qualities, including relative availability and safety and so forth. However, there are a lot of advances in certain areas, and there are a lot of potential changes in other areas that are coming. So in this video, we will talk about two separate possibilities, each of which will have a slightly different effect on the readily available and practically useful explosives of the future. Now, I want to start off by acknowledging that this is a dangerous topic to discuss on YouTube. This is probably pushing some of the standards, not standards of reality and safety, but community standards. My kid's favorite YouTube channel right now is Nile Red, and he is I would say, deeply inoffensive Canadian chemist. And he has actually lost a bunch of his YouTube videos. They've been pulled by the algorithm, or possibly even YouTube humans, because they describe basic chemical processes. So in this video, I'm afraid I'm going to have to be slightly vague about basic chemical processes. But first, I want to remind you that explosives, while offensive to certain terms and conditions of community standards, have nevertheless been a very big part of modern life, ever since explosives were developed. The explosive power that you have when you're doing quarrying or mining or earth moving is a big deal. This is one of the reasons that Alfred Nobel became such an incredibly wealthy man. Once he had stabilized nitroglycerin, made it safe for everybody to use TNT and dynamite, once he created an explosive that was safe to transport, anyone could use it, everyone did use it, and that's just an important part of history. And I want to remind you that chemical energy is fantastic. It's just so powerful. You know this because gasoline and gunpowder are still some of the most energy-dense fuel sources, and you use them perhaps not every day, but on a pretty regular basis. Now, in the 21st century, almost all of the attention recently has been on electrical energy, and all of our electric energy is supposed to be coming from renewable sources, so that kind of takes away from chemical energy, but that doesn't make it any less powerful, and it doesn't make it any less useful. If you want to create, for example, a lot of pressure or a lot of heat or a lot of light very quickly, chemical energy is the way to do it. And if you want to create a lot of smoke, well, technically you can kind of do this with electricity, but it's a lot easier just to burn stuff. Now, I think one of the most interesting things that was tested in our civilian explosives video were the parachute flares. Putting an incredibly bright flare up into the sky is just way faster and easier using chemicals than, say, a drone with a whole bunch of high-powered LEDs. And then, of course, that thing is disposable. You don't have to recover the drone and the lights if you are moving around. And there's a lot of flexibility with some of these different chemical fuel packages, because different chemicals emit different wavelengths of light. So you can make illuminating flares that specifically kick out infrared light, which is very handy for you guys that are running night vision. Now, general rule of thumb is that when things are burning, they often emit a lot more infrared light than visible light anyway, so just kind of tuck that away. So, just to begin, let's think about all the different ways that chemical reactions, specifically the hot chemical reactions, can do work that solves problems. There's a whole bunch that you might not even be thinking about, like aircraft oxygen masks, for example. Those, when they drop down from the ceiling and the bag does not inflate, they're still being supplied by oxygen, not from pressurized oxygen tanks, but a chemical candle that is burning. And as that fuel burns, it produces oxygen instead of consuming it. And this way of producing oxygen is just way lighter and smaller and less maintenance intensive than a pressurized oxygen system would be. So there's a lot of room for us to revisit some of this stuff. This was back when Disney Pictures was a proper film studio. Walt Disney was still alive and they were still making movies where a 9-year-old boy could kill pirates with coconut bombs stuffed with gunpowder.
Now don't go down.
Those were the days. Black powder is in the past. It's very easy to make, it's very easy to ignite. We've had it for centuries, it's not going anywhere. But while Disney films have gotten worse, chemical explosives have gotten better. There's been a lot of advances in chemistry, meaning better yields, but also better stability, and sometimes at the same time. Then we've also had some advances in physics, which have made explosives more useful. Think about things like shaped charges, the ability to focus the application. Basically, ways of doing more work with less cost or less danger. Now, today, in the United States of 2025, not everybody needs explosives. Well, so we're told anyhow. But explosives and other chemical volatile tools are so powerful that there could be some change in a relatively short space of time where more people see the use and actually more people actually use them. Right now, explosives are pretty restricted to specialists, but they have undeniable general applications. So let's talk about those two possibilities where the specialized nature of explosive application would change and the general civilian use of explosives would increase to higher levels. One possibility is continued technological growth inside times of great peace and prosperity. The other is the opposite of that. So, to talk about scenario one, let's say we continue to have this current trajectory of technological advancement and security. Things continue to cruise along as they have for the last few decades or so in the United States, which gives people time to do all sorts of fun, cool experiments. And we've got a bunch of new, interesting tools that really fit experiments in this volatile chemical process space. Very energetic materials. Let's talk about 3D printing, micropipette devices, different chemical mixing tools, and so forth. High explosives, generally speaking, are pretty difficult to arm if they're safe. But there's a lot of advances in microelectronics that also will lend themselves to better ignition, but I'm afraid that YouTube probably doesn't want us to be much more specific on initiation. And this is also where I want to put our first safety warning, and that is that explosives, when used properly and improperly, are incredibly dangerous. Earlier this year, we had a very significant explosion at the AES factory nearby. Even though the building that detonated was miles and miles away, we heard the explosion and felt the explosion from inside of our houses right here at T-Rex Arms. A number of people were killed. It was the largest mass casualty event in Hickman County probably since the war, when the Yankees invaded. This is a very significant issue for you guys to consider. These experiments that I am talking about hypothetically and potentially happening need to be done by people that take them very seriously and know what they are doing. But there are some chemical advances that make things a little bit safer. You guys know about binary explosives because of tannerite. This is a very common idea. Two substances that are not spicy on their own, which become more volatile when mixed. Not only is this a safer way to transport individual components in their more stable forms, but it's also a legal way for you to own combustible components when they're separate. It's also a really good way of having munitions which are disarmed until firing. We have a number of different mechanisms inside of military munitions that make them safe to transport, and then either a fuse is added at a specific time or a fuse is armed at a specific time. And binary liquid explosives have some very interesting characteristics that lend themselves to safer and smaller quantities, safer transport, but also they are really easy to mix in certain circumstances. It would be a fantastic application for, say, inside of a small warhead. The materials are separated by 3D printed baffles, and then when it is fired or when it engages the rifling, when it is the propellant is initiated, all of a sudden those things combine to create the final product, just as an example, which we're not going to show you any pictures of because YouTube would complain. Now, this is not a new idea. You have seen a scientific demonstration of liquid binary explosives being combined together on screen in the classic non-Christmas movie Die Hard 3.
Two liquids. Now, either one by itself, you got nothing. But mix them. Charlie! Like I said, very cool stuff.
Just for reference, Die Hard 1, Christmas movie. Die Hard 2, also a Christmas movie. Die Hard 3, not a Christmas movie. Die Hard 4, not a Die Hard movie. Die Hard 5, not a movie. But let's get back to the explosives. The other thing that liquid explosives offer is the ability to shape the explosive charge into very specific forms. And you can do that by putting them inside complex 3D printed geometries that will focus the explosive force into very specific shapes and do very specific things. Now, you know about shaped charges because this is a very important thing that has been developed for punching holes in armor and doing very specific cutting or penetrating tasks for other military applications. And if you have the ability to 3D print different forms and just fill them with your liquid explosives, you have all kinds of new applications available to you at a really short amount of time. Rather than carry around a whole library of different shape charges for very specific uses, you could just carry around the liquid components safely in separate areas and then just 3D print the shapes that you need for the specific warheads that you are looking for, which in the military context allows you to shorten your supply lines. It adds a whole lot of versatility to some of your tasks, which is great if you're operating in foreign environments, but it's also great in that civil sphere when you're a relatively small company and you're dealing with all kinds of different constructive or destructive tasks in different applications. The other thing that I think is going to affect our development of some explosive tools and allow for some relatively cheap and safe experimentation are 3D simulations. You are now looking at an explosion that is being simulated in real time using a 3D animation tool called Embergen. Embergen is a plugin that works with a whole bunch of real-time engines and a whole bunch of animation tools. And I realized that there's a very significant difference between simulating an explosion in a compressible fluid simulator for an animation package and one that does actual proper physics simulations for a predictive engineering tool. But I would say that that difference is probably only about 3 or 4 years. So, as people have access to better simulation software, better additive manufacturing technologies that allow them to work with different tools, as those liquid control tools like those automated micropipette CNC machines and various other mixing technologies come into effect, ultrasonic mixing and things like that, there are all kinds of new opportunities for people to do small engineering experiments, mix very precise amounts of explosive or non-explosive chemicals at very precise rates and do this remotely and safely. It's all kinds of opportunities for small chemical shops that would like to provide new opportunities. Now, this is the time when I mention safety warning number 2. As you have probably seen from YouTube, when you mix binary explosives together to make tannerite, tannerite is this dumb explosive, but somehow it always manages to send shrapnel directly towards the cameraman. Shrapnel will kill you, but you can hide behind metal or various other types of cover and escape the shrapnel that is hunting you down. What you probably are not thinking about, if you're watching these videos, are the shock waves. The shock waves, the pressure waves from some of these large-scale detonations will actually hunt you down and find you behind cover. Hollywood has sort of tricked you. They've made Hollywood movies that show nuclear bombs and invisible radiation being far more deadly than it actually is, but Hollywood has also made conventional explosions look way less dangerous. As we all know, if you're just cool enough, you can walk away from an explosion without looking back at it and be totally unharmed. But that pressure wave will not just pulverize your brain, but it will follow you into buildings and around corners and behind cover and get you.
Walk away in movies without flinching when it explodes behind them. There's no way!
So I just want to say, all of the development in this space should be done by people who are doing the work to understand these things, because misuse or mistakes are incredibly costly. And every bit of development that we're talking about so far in this space lends itself to warfighting and destructive explosive applications, which brings us to scenario number 2. If things do not stay smooth and stable with lots of civil applications for new explosive technology with lots of cool experimentation to develop neat new stuff. If you are plunged into, say, some level of national or local military conflict, then yes, obviously explosive use gets a lot more common, and you may not have time or capacity to do the really fancy new research into cool initiators or liquid-based charges. But what history has taught us is that civilians will also have access to a lot more explosive materials and tools and use them very widely. If open war and direct military action is in close proximity to you, then military-grade explosives are also in close proximity to you, and you will probably have access to them in some capacity. If you look at Ukraine over the last 3 years, there's a lot of fuzziness between combatants and civilians. There's a lot of commercial off-the-shelf drones carrying military warheads, and a lot of collaboration between people sitting behind each set of helmets. And a lot of military warheads are really ideal sizes to use for different tasks. You got your 40mm grenades, you got your mortar shells, you got your artillery shells, all different sizes of high explosives with fuses, relatively stable, relatively accessible, and they get used for a lot of different things. Now, wartime is a high-risk, high-stakes time for civilians as well as military guys, and so civilians often will find themselves using military explosives for regular tasks that they undertake during the duration. So things like digging trenches or using det cord for cutting down trees, basic earth moving, etc., that used to be done with basic tools, sometimes gets done with military explosives that just kind of get used for civil applications. And a lot of trading happens between these two different groups when they're trying to do the same stuff together. Great example of this would be C4, a fantastic, stable, high explosive for military use, but in wartime, sometimes it is used as a very basic fuel source, even by civilian populations. This is so widely known that even Mythbusters tested this possibility.
What's with the stove?
It is our next story.
It's about cooking?
Sort of. It is a military myth, and it's about replacing your normal cooking fuel with something usually considered far more destructive.
That brings me to safety tip number 3. You should also watch out for fumes if you're cooking food directly over C4. You better like the taste of some specific chemical compounds that YouTube doesn't want me to mention by name. But just remember that some of these chemical compounds can be very dangerous to humans even when they don't explode. So once again, knowledge is power, and you need to understand this stuff. But to sum up this video, my main point is that when it comes to chemical fuel sources, when it comes to chemical energy, there is way too much power on the table for things to stay static where they are right now, with a lot of electrical use in civilian times and almost no chemical energy being utilized. Rapidly acting chemical energy tools, for lack of a better name, offer too many benefits in too many areas not to get used more. Either the new technology that gets developed will provide more benefits, resulting in more R&D and then more use than today, or the needs will be greater. So more use of chemical power than now will happen. This is something that I think we should start thinking about now while we're still able to get ahead of some of this stuff. But that's not to diminish the importance of electrical power. That's something we'll be talking about in next week's video. Ultimately, everything is downstream of energy. YouTube is an interesting place right now with a whole lot of rules changing and a whole lot of different algorithm changes. We have a question for you. I specifically would like to know what is useful for you, the viewer. What kind of topics, what kind of information are you looking for? Over the years, we have made YouTube videos about stuff that we want to talk about. And sometimes we've had to jump through a bunch of hoops and be vaguer than we would like because of those YouTube policies. And maybe we should be making that type of content to put somewhere else. But our purpose in running this YouTube channel at T-Rex Labs and the main channel is not just to have a space on the internet. It is not to grow a YouTube channel to be a YouTuber. It's not even to be a gun tuber. It is to provide educational content for you guys. So I really want to hear what is the stuff that is most interesting and is most useful, and what is the stuff that isn't being done by other people. And then we can figure out whether it's the sort of thing that is allowed on YouTube or not.